Hello, today I'll be doing problem 12 from chapter 4. In this problem, two forces are applied to a car in an effort to move it. As shown in this figure, what is the resultant of these two forces if the car has a mass of 3,000 kilograms, what is the acceleration? This problem has us ignore friction because that's going to come up later, so you don't have to worry about that. First, we have to map up this diagram. Here, I've already mapped up this certain diagram. First, I've set my x direction as going positive up, and my y direction going positive right. Here, I've labeled my forces. The 450 newtons going left at 10 degrees is going to be F1, and the other one is going to be F2. Sorry about that. First, we have to find the forces in the x and y. I've set it up so Fx is F2's x minus F1's x, because again F1's going in a negative direction, and Fy is you just add them. To solve this, we notice that these form right triangles, so we just have to use trigonometry. Here we use sine instead of cosine, because as you can see, the sine is basically how far x is, and basically cosine and sine have switched. So to solve for sine for F1, you just have to put sine of 10 times 100 times 450. You do the same, except you do sine of 30 and 400 newtons. You plug them into the equation and get roughly 121.86 newtons. You may have a different answer than mine because I rounded to the nearest hundredth. Here we use cosine to find y. Here we have cosine of 10 times 450 is F1's y, and we just have to replace the 10 with 30 and the 450 with 400 for F2's y. Add them up and we get 789.57 newtons. To solve this, we're going to have to use the Pythagorean theorem to get the final force. So we just use Pythagorean theorem and get around 798.92 newtons. For B, it's a lot easier. You just use the force formula. Force equals mass times acceleration. Plug in our force and plug in our mass. And we get the acceleration of 0.2663 meters per second squared. And that's all is to it. Thank you for watching. I hope this helps you in the future.